Hello everyone, welcome back. We are in the 12th week of this course on reinforced concrete design, and this is the 7th and last lecture for this week also for this course. Now in this lecture we are going to study the time history analysis of this structure where we apply ground motion. And in fact, we have already studied response spectrum, and now you know the meaning of response spectrum. So what we'll do today, we'll apply a ground acceleration, and then we will solve the time history response. As you can see here, time history definition is there. So we'll solve for time history response. But for the time history response, actually, we normally use a recorded accelerogram. So if you use a accelerogram which may be recorded at a different place and try to use for this structure, which is now located in Guwahati, so what we have to do, we have to make it spectrum compatible. You know response spectrum definition, so we have to make it spectrum compatible, meaning that if we use directly that earthquake and produce a response spectrum, then we may not get the design response spectrum as specified in the code. So for that, what we have to do, let us see how we can make it spectrum compatible. So we are going to use a recorded accelerogram. As you can see, it is called El Centro earthquake. So we read this accelerogram from a file. Here there are different options. You can see time and acceleration values per line. So let us select that because the file is written in that way. So the original El Centro record, if you open it, you can see that the first column is time and the second column is acceleration, right? So here we read from the first line. Normally accelerogram records, they come with a header file, so we can start reading from a different file. You can also read multiple accelerations in a single go. However, for our case, we have only one acceleration. So let us go back to the previous setting. And here you can see the time step delta t that you can read from your file. So it is now for our case 0.01. And the last time point is automatically selected. And we have a scaling factor also. I'll come to that in a minute. But you can see also acceleration column number, that is 2, and the time column, that is 1. So here you can see the acceleration plot which is in G. Okay. Now you can see this recorded acceleration. If we develop a response spectrum using this acceleration, obviously we will not get the desired design spectrum that we have in our Indian standard code. So that's the reason we need to make sure that we have an accelerogram that is compatible to this type of design accelerations, design response spectrum. So for that again, we can here define different response spectrum in the software. This is called SeismoMatch. You can download this software. So we can load a specific spectrum or we can go for a code-based spectrum. So let us select the IS code, and the moment we select, you see it is a elastic spectrum, and if we set the zone factor correctly, Z value will come, and for the soil type we select medium, that is B, and importance class is 1, so we select rest category. Now you can see the design response spectrum here, and for that we have to go for matching, and we select the maximum period. As you can see, the design response spectrum is defined up to 4 seconds, so we select that. Now this tolerance, you can actually reduce it. For that you have to go for a paid version, otherwise you can go for this default setting, which is 30%. Even if you set lower value, it will not go. I will come to that again when we will have the matching. So let us go for this matching of this spectrum. So there is a theory behind this matching. Again, we are not going into the details of that. Now after matching, you see we have the accelerogram here, which is slightly different than the original one. And that's why it offers the design response spectrum. Not exactly. We can reduce this matching, this tolerance, but again, you have to have the full license for that. Even if you set lower values, it will not accept. Here you can see the time histories of the original accelerogram. So we have the acceleration, velocity and displacement. Then matched accelerogram, you can see acceleration and velocities are quite appropriate, but for the displacement, you can see there is a trend. For the time being, we are not interested of displacement. So we can do our analysis with the acceleration only. And then this is the original response spectrum. This is the design response spectrum. And if we use the original record, we get this response spectrum, which after matching comes close to the design response spectrum. And as I told you, if you reduce tolerance, you can have a better match. That's not possible here in this free version. Then here you can see the table. In this table, you have the original accelerogram and the matched accelerogram. And then again, here you can see pseudo accelerations. For the time being, let us ignore that. So we have time period versus acceleration and also the time histories. Now, those time histories we can save. And once it is saved, we can use that file for the time history analysis. Now, the accelerogram is spectrum compatible. So the design spectrum is as per IS 1893 and the location is Guwahati in zone 5. And for that, the saved accelerogram is appropriate because now it is spectrum compatible. Otherwise, you cannot use the raw accelerogram, then the time history analysis will be wrong. So let us save it. So once we create the file, it is saved. Here you can see the matched El Centro. If you open it, you'll see the time and acceleration values, but that is in G. Okay, just keep that in mind. I will come back to it. We have to adjust that because we have to get the response in meter per second square. If it is acceleration, obviously. So what we do is select these two columns and then save it in a text document, which we'll read from the StatPro for our time history analysis. Now, we have to define the time history. So for this time history analysis, we have to set the integration time step for this numerical integration. So let us keep that time step same as we have in the original acceleration record. So you can define time versus acceleration. We can also read from the file. So if we set the file name here, the file should be in the same folder. So then it will read it automatically from the file. It should be in txt.txt format. So here you see it is defined. Now arrival time, let us set it 0. So at the initial time point, it will start the acceleration. We can also set a different point. Now you can see damping is also 5%. The reference mass for modal analysis we added earlier. So let us keep that reference mass same. And we have these load combinations earlier selected. So let us delete that. Today we are going to do a time history analysis and see the time history response of the structure. Design has already been done. So let us delete these load cases. There are two response spectrum analysis load cases. Let us also delete them. Now we have to add a time history load case. So it is seismic, and the time history is applied along x direction. So it is now applied. Now here, recall the time history is in G. So here you can select the time load or ground motion. For our case, it is ground motion. So let us select ground motion here. Direction is along x. Arrival time is 0. And here you see the defined type is acceleration, and the force amplitude factor we have to apply because the original accelerogram is in G, so we have to multiply that with 9.81. So here we have to set the force amplitude factor as 9.81. So now we consider the reference mass for this analysis. Recall this reference mass was added during modal analysis, and it contains the total mass of the structure because that is necessary for dynamic analysis. So now let us go for the time history analysis. So let us run the analysis. Let us view the output file. And again here you can see, you can go to the concrete design and you can see the details. So now let us go to post-processing. Let us select only the time history load case. Because we have already designed, today we will see how the time history response of this structure look like. So here you have the complete list of displacement and rotation. So you can select the time in seconds, and then for that you can select a node and you can see the response of the structure. So you can see the deformed shape here. And for that particular node, you can see the displacement along X, Y, and Z. So we selected node number 173, and then you can also save it. You can select multiple nodes, and then for that you can see the time history response, as you can see on the right hand side of your screen. Likewise, you can also select a list of nodes like this time we have 177, and for that we have X, Y, and Z component of the response. So likewise, you can select all the nodes and see the displacement. So from these displacements, you can also find out interstory drift that is required for your design. So all this you can save in data file. So just right click and save that, and then from there you can also find out the interstory drift which is used for RC design, right? So you can save the data. So that is displacement along X for node number 212. Likewise, you can also save other displacements. So with that, you can actually save. Here you see displacement for 212 node is saved, and here is the complete list. For all time stamps, you have the displacement along X, so you can change the direction, and then also you can save it and do the rest of the analysis. So here is the response for the node 1. So you can do the animation. You can see the deformed shape. Here you can change the scale. And now you see the deformation of the building. Of course, it is for a particular time point. So accordingly, you can change the time point and see the deformation corresponding to that particular timestamp. So here again it is 35 seconds. So if it is 15 seconds, then you have the a response. So you have to set the time point accordingly, and then you can animate. So with that, let us close here. If you have any doubt, do let us know. We'll clear your doubt through emails. And let us close our lecture here for this course. Thank you very much.